Screen is visible?
Yes, sir.
Okay. So thank you, Prashant, for an extended introduction. As already spoken by the various speakers, the course is mainly on the aspect of digitally controlled power electronic converter. It is basically the power of the brain which control the muscular power. The muscle power is provided by power electronic converter, but ultimately it is the brain who control the activities of the human body. Similarly, all power electronic converters have revolutionized the industrial, residential or domestic applications because of the availability of very accurate and precise digital control techniques. The use of artificial intelligence to inculcate the control aspects in power electronic converters is experimented and successfully implemented in various applications. Fuzzy logic control is among one of them. While implementing the control, we need to model a particular system. And as you all are aware, when we study the electrical engineering theorems for mathematical modeling of any particular system, we start with any linear bilateral network. That means all these theorems are valid if your system is linear, your system is bilateral. Moment we talk about power electronic converters, they uses the semiconductor devices as a switch. And these semiconductor devices are unidirectional, maybe a diode or SCR or any other self-commutated device. So moment we introduce any semiconductor device as a switch, it basically does not meet the criteria of bilateral network. Immediately, your system will become unilateral. At the same time, non-linearity is involved because a power electronic converter fade load does not follow the Ohm's law, where the shape of the current is much deviated than the voltage waveforms. Conventionally, most of our loads were in the form of motors, that too induction motors, though they draw reactive component of current, but current remains sinusoidal as similar to the shape of the voltage. But moment we introduce power electronic converter, the Ohm's law is also violated. And when it comes to modeling a system, we have to make certain assumptions to make the system linear. Moment we make our system linear with certain assumptions, we introduce error into the system. And using the power electronic systems, our mathematical modeling becomes much more complex. To implement the effective control in non-linear systems like power electronic converters, use of artificial intelligence, that is neural network and fuzzy logic based techniques are being introduced. As far as fuzzy logic is concerned, it is basically very similar to human thinking. So in fuzzy logic control for power electronic converters, we basically expect a machine to implement effective control with the help of input provided to the system in an effective way with less accurate mathematical model. And that is why fuzzy logic has gained the importance in the control of power electronic converter, how it is effective, how it can be implemented. All this we will try to understand through this discussion. Now, before actually we talk about the different issues, let's just talk about human machine interface in the form of an artificial hand. For an artificial hand, let's see, a brain will send this signal, and there is a need to sense these signals. These signals are filtered, then analyzed, and based on analysis, certain commands are issued for execution of a particular task. Let's see whether opening or closing of your wrist movement. So close your hand. This basically command is issued by my brain, and the action is executed by my wrist movement, finger movements. These commands are being issued and they are communicated through the muscle. When we expect a machine to take a decision, there is a need to sense these commands and recognize these signals for effective implementation. Let's see if we talk about the identification. So if we ask to identify the animals, we can say these are animals. This is not an accurate reply, not an accurate answer. It's a vague information that these two pictures indicated they are basically animals. But to be more accurate, we can define them as either horse and this one is donkey. So this is a very specific identification that this picture is indicating a donkey, this is indicating a horse. Can you basically interchange the name of these animals? Let me call this as horse, this as donkey. Perhaps the information is correct, but not accurate. Based on the characteristics of these animals, they are characterized as horse or donkey. But based on certain inputs, certain information, we try to recognize. So basically, moment we see these picture, our brain will recognize and will immediately identify the species. This is horse and this is donkey. Let's see if we talk about the pattern recognition. The pattern recognition, say alphabet A, alphabet B. So basically our brain cells are trained. A child when go to school, he basically learn. We basically ask the child to learn these things through pattern recognition. We ask them this, identify this particular pattern. This is A, this is B, and so on. Let's see, this is mirror image of B. So we have clearly recognized this particular pattern as, let's see, if we talk about these two patterns, this is P, but this is maybe a mirror image of P, or we basically know, my brain cells know, this is not a mirror image, this is Q. Because this is, I have learned this alphabet is P, this is Q. Similarly, this is B and D, not the mirror image. But we might have seen a child while learning, you ask them to write P, they will write Q. You ask them to write B, they will write D. And the reason is the brain cells are not trained perfectly. And because of that, this mistake is being done. Many times you ask them to write M, they will write W. So what do? We correct them. The teacher correct, this is P, this is Q, this is B, this is D. And with some more practice, our brain cells are further trained to recognize a particular pattern. So all these are the decisions we are taking based on some information and some intelligence involved. So basically what we can say that our brain cells, after learning something, is able to take the right or accurate decision. This is what we want in fuzzy theory, that a machine should be able to take a decision to control a particular system. Now, let me take another example from day-to-day life about automatic washing machine. Machines are two type: fully automatic and semi-automatic. So you can see this is the picture of a semi-automatic washing machine. We have two different tubs. This is wash tub and another one is the dryer. We have certain commands on the panel. There is a wash timer, wash or drain operation selector is there, whether you wanted to go for wash operation or drain operation, and then we'll have the on off control. Now what actually happens in semi-automatic washing machine, we the machine perform the soaking operation, washing operation. So you have to pour the water for wash operation as well as the detergent to be added. How much water to be added? We take a decision based on our intelligence involved, and you must have seen there are some indicators given: 2/3, 1/4, or full. That you have to fill the machine up to these particular levels. So some intelligence is required how much water to be added for washing operation. So very basic learning experience we have, that how much water to be added till all your cloths will be merged into the water, isn't it? Then after the completion of the wash operation, for drying operation, you need to switch the tub. From wash tub, we have to put the cloths into dryer. So all the time we are busy. Though machine is performing a particular task, but I am all the time busy in my job, loading the machine, putting the water into the tub, draining it, again putting for rinsing operation, changing the cloths from wash tub to dryer. And of course, some timing is required. How much time is required to wash? Again, we take a manual decision. Okay, how do we take? This is again based on my intelligence involved. I know something. How much time is required for the wash operation? आप लोग कपड़े धोते हैं, कितनी देर तक वॉशिंग कर रहे होते हैं? Basically, I know till all the dirts of the cloth is removed, isn't it? How do we do? Manually. Same thing here in semi-automatic washing machine. We put the timer. If your cloths are more dirty, आपने देखना है 5 मिनट तक मशीन चलाना है, या 7 मिनट चलाना है, या 10 मिनट चलाना. Okay, so by that time, उतनी देर तक some spindle movement is there and the cloths are basically rubbed for cleaning purpose. So in fact, we have our experience, we apply that experience to perform this task, but though I'm using the machine, but at the same time, the person or the operator who is working on the system is engaged all the time. And you so all these difficulties are being eliminated in fully automatic washing machine. But the issue is instead of changing the cloth from one tub to another, fully automatic washing machine will have only one tub. So all the operation of soaking, washing, rinsing, drying are performed in one tub only. We'll have a spindle there with a different kind of shape. And what happens basically, this spindle rotates to perform the wash operation, isn't it? Now, on a semi-automatic washing machine, we have certain operation, a knob is there to set gentle wash, moderate wash, or heavy wash. What does it will do? Basically, if you go for a heavy wash, that means our cloths are very dirty. What you want? Large rotation. That means rubbing with high force, high pressure. That is what we do in practice. So that is basically performed with the help of this spindle movement. For a heavy wash, we basically allow the rotation of this spindle to a larger degree, say maybe 180 degree or 170 degree. For a gentle wash, we want slow spindle movement. So for that, certain inputs needs to be given. So in fact, there are many more inputs are required. Just for simplicity, I have selected two only. We have selection of washing cycle and washing time. How much spindle rotation is needed, whether it is gentle, moderate, or very heavy. Heavy or maybe very heavy. And then how much washing time is required. How to basically select how much washing time is required. If I'm doing a manual wash, I can take a decision. I have to rub the cloth until we are not able to remove all the dirts on the cloth. So similar kind of things are need to be implemented. So in fact, what do? We'll take a decision. Yes, my clothes are not much dirty, so I wanted to go for a light wash, gentle wash, or moderate wash. Okay, so that will decide the washing time that needs to be selected automatically. So what do we do? Basically, certain inputs need to be provided. So as you are aware, all the machines, they are available in the load capacity, isn't it? 5 kg machine, 6 kg machine, 6.5 kg machine. Basically, that is the load of the cloths put into the washing machine. So capacity of this tub, which is being basically weighted. So some sensor is there, load sensor is there, that will basically give the information to the controller that how much cloths are added, whether machine is fully loaded or half loaded or 2/3 or 1/4. That is the basically input for taking the decision how much water to be added into the tub. If your machine is half loaded, that means half of the tub will be filled with water. If your machine is fully loaded, that means whatever the optimum capacity of this tank is there, so how much, that much of water is allowed to enter into the cloth. What machine is taking these decisions automatically? What does it do? It will open the valve for that much of time duration. Then the second input is softness of the cloths used. What type of cloths you are using, isn't it? So you might have seen, we generally use, are you aware, there is the cloth wash available known as EG. EG is generally used to wash the woolen cloths, soft wash, isn't it? That is much more expensive. Whereas the cloths like towel, bed sheet, curtains, we use a low cost detergent. That means which has high quantity of caustic to remove the dirt. So basically, we have to take a decision what kind of cloth I am washing. It is my shirt of brand Ellen Soli. Then how do? We wash it very gently, isn't it? यदि आपने जोर से ब्रश लगा दिया तो हो सकता है कलर आपका खराब हो सकता है. It's a very expensive, 2,000 rupees you have paid for this shirt. So we want a gentle wash. So that means the softness based on the type of cloth you have to choose, and then finally we'll take a decision about how much time is required for washing. Similarly, that washing cycle selection, that is gentle or moderate or heavy wash. So in fact, what is happening here, we are programming the machine. In fully automatic washing machine, what will happen? Load the machine, switch on the power, and forget everything. Your machine will take all the decision, how much water to be added, how many time wash operations required, what is the soaking time, what is the rinsing, how many times rinsing is required, whether twice or thrice, and how much water. That is the most important thing, that we need to control the water. Does not matter if I am washing a hanky only, you will not fill the entire tank fully. isn't it? So if your cloths are less, the water quantity to be removed for every cycle of operation. That is basically optimum use of the resources, and that need to be taken care. So this is a very perfect example where human intelligence is required to perform a controlled task. If you do remember, first time the Whirlpool has launched fuzzy logic control washing machine. There was a big advertisement those days on TV channel, fuzzy logic controlled washing machine. Now, as on date, every washing machine manufacturer, automatic washing machine, they basically introduce fuzzy logic control. So fuzzy logic control chips are available in the market. You have to give some input through sensors, and the controller will take the decision to perform the task. So this is an example where we are using the nature of human decision making. So our goal is simple and auto operation of machine with high quality. So what is happening? We are now free totally as compared to this semi-automatic operation. Load the machine, shut it, switch on the power, forget it, and you will get the dried cloth at the end of the washing cycle. So you are basically free during that particular period. Go enjoy some another job, take rest, whatever you wish, you do. Machine will do the task with, of course, what we want is that your wash quality should be close to what I am doing it manually. So now coming to this particular, we'll now compare the fuzzy as well as the crispy logic. So in fuzzy logic, basically we have the vagueness. Your system is uncertain, inputs are uncertain, imprecise, qualitative, maybe not necessarily yes or no kind of thing. Whereas in crispy, they are also called a Boolean logic. Your basically inputs are fixed. They are in the form of yes or no, high or low, or simply the binary logic, either 0 or 1. There is nothing in between. So your inputs are certain, finite, very precise, and they are basically quantitative, either yes or no, 1 or 0. If I'll say high or low, there is a significant meaning of high means plus 5 volt, low means 0 volt, or practically something with some tolerance. So in fact, your machine thinking is crispy or Boolean, where you have to give the exact input, whereas the human thinking, it works on fuzzy logic. It works on vague input, uncertain input. Say for example, if we take the example of washing machine, how much water to be added? Now the answer cannot be 10 liter, 15 liter, 20 liter, isn't it? Whereas crispy logic will exactly give you how much water to be added. 15 liter डालना है, 18 liter डालना है. Whereas how do we do actually? We have to add the water till all your cloths are merged into the water. So we are experienced enough. What do? We start pouring the water. We are observing. As soon as we see all the cloths are merged into the water, yes, now we can say stop pouring the water into the tub. So now all these vagueness is to be incorporated into the machine. Let's see how we are able to do that. So we'll see that all these logics are inspired from the nature. The artificial neural network, we call it a training method, whereas fuzzy logic is known as decision making. We take some imprecise input, analyze it, and will take certain accurate decision. So in fact, what we'll say that fuzzy logic, it is the form of the artificial intelligence. It is basically argued that human thinking does not always follow crispy yes or no, but it is often vague, uncertain, indecisive, or fuzzy. Say for example, an student appearing in class 12, he is basically fuzzy. In fact, rather a student who is in class 10, he is rather more fuzzy, which profession to opt for, whether to go for the engineering, whether to go for the medicals, or for commerce side, or for art side, which subject to choose. So basically your thinking is fuzzy. If you take mathematics, You can become an engineer. You can also become a IAS officer. You can also become a maybe IPS officer. You can also go for maybe statistics, something like that. Now you have to give the kind of information what you wanted to go for, which particular profession you are choosing, and then so your decision whether you are willing to choose mathematics, maybe yes, I want to become an engineer, perhaps I must choose mathematics. No, perhaps I'm also having the interest in biology, I also wish to become a doctor, but for medical there are very limited seats, so in fact chances are less. That is why I will opt for this particular. So this is basically the human thinking is very fuzzy. It's not crispy like yes or no. Decision making is very complex, and our brain is competent enough. We are trying to replicate the human thinking to take the decision by the machine. Now, if we simply talk about the traditional presentation of these logics, so let's see these two species, we can very well say this is slow, this is fast. So if you need to digitize it, the speed is 0, the speed is 1. So 0 means slow, fast means 1. Okay, so you can write a logic. If speed is 0, speed is low, else speed is fast. And so in fact, my logic is very clear. But now let's see, instead of 2, now we'll have 4 different objects. Let's see, let me take another example. We have 4 different mode of transport. If we have the bullock cart and car. So bullock cart is slow, car is fast. My decision making is simple. But let's see, I have bullock cart, a bicycle, a motorcycle, and a car. Then probably I cannot say that this is slow, this is fast. Rather, we have to have the relative terminology. Bullock cart or this particular species slowest, slow, fast, and fastest. Let's say if this is a car, we'll say fastest. Now, what is the meaning of slow, slowest, fast? You have to have some numerical values. So let's see for a bullock cart, 0 to 5 kilometer per hour. For a bicycle, maybe 0 to 15 kilometer per hour. For a motorcycle, 0 to 60 kilometer per hour. For basically car, 0 to 100 and 120 kilometer. So definitely now the definition has changed. Instead of slow and fast, I have slowest, fastest. So some decision that let us see 0 to 0.25 slowest, 0.5 to 5 slow, 0.5 to 0.75 fast, and 0.75 to 1 is fastest. So what I did is that I have normalized the input, either 0 to 0.25 or 0 to 25% or 0 to 0.25 per unit, or 0 to 100% or 75 to 100%. What do? We will basically write on a horizontal axis. So basically LHS side, it is slowest, RHS side, fastest. So what do? 0 to 0.25 slowest, 0.25 to 0.5 slow, 0.5 to 0.75 fast, and 0.75 to 1, we call it fastest. Then again we'll write an if then else statement. If your speed is between 0 to 0.25, it is slowest. Else if 0.5 to 0.25 to 0.5, it is slow. Else if 0.5 to 0.75, it is fast. Else, that means if it is greater than 0.75, fast. So this is how basically our human brain think in terms of if else kind of thing. If you wanted to go to Delhi within the shortest time, air is the best option to travel. But at the same time, you have the constraint, whether you have enough money in your pocket. If not, then you have to look for another means. No, it is better to travel by train because it is a faster way, but economic as well. So this is how if else kind of things are taken. Now, we have to have these inputs to be precise. What is the meaning of precision? So precision, let's see, this weight is falling on this man's head. Another fellow who is watching believes in precision. So he is giving a precise information. A 1500 kg mass is approaching your head at 45.3 meter per second. So very precise and accurate information. But do you think that it is necessary? If this fellow also believe in precision, if he starts calculating that this weight with this speed, it will take this much of time to reach my head, probably he will no more be there. What is needed in this particular case? We simply want to warn, please get away from this place. You are in danger, whether it is 1500 kg or 500 kg or 50 kg, whether it is coming with this pace or not. So in this particular case, no precision is needed. We have to simply warn. That should be my objective. So that is basically, we'll say, Professor L.A. Zadeh, who is the founder of fuzzy theory, what he said, as complexity rises, precise statements lose meaning. Here, this is precise statement, but there is no meaning. This is imprecise, but it has a meaning. So what Professor Zadeh said, as complexity rises, precise statement lose meaning and meaningful statement lose precision. There is a meaning here, but there is no precision. So basically, we have to, this is the key of fuzzy. Do you really need a complex precision? If not, then take the decision accordingly. Then what we have to learn to do, we learn by doing. So just take the example of washing machine. We have developed a control algorithm based on our knowing, based on our learning how much water to be added, how much time is required to wash the clothes. This is my experience. I know from my experience, and this experience is basically applied, is implemented with the help of digital control for effective and accurate decision making. So conventionally, if we talk about, there are many modern control theories: state feedback controller, self-tuning controller, model reference adaptive controller. The issue, the difficulty is that all these controllers require accurate mathematical model and therefore sensitive to parameter variation. If your model is not accurate, the chances of failure is there. If your information is not accurate, your controller may fail. On the contrary, basically a fuzzy, the advantage of fuzzy logic, the advantages of fuzzy logic is it does not need accurate mathematical model. That is what the biggest advantage of fuzzy theory. I'm not saying it does not require a mathematical model. It does not need an accurate model. So that means make a rough model, make a crude model, and based on your the learning or experience, apply the control and check the decision making. It can work with imprecise input. If your input are not precise, it can handle non-linearity, and that is what we are talking. All power electronic systems are non-linear, and it is more robust. In some cases, it is proved that fuzzy control is better than the conventional control and more robust. So basically, just to summarize, it is a form of artificial intelligence which is development of computer program based on human intelligence. And fuzzy logic, unlike Boolean, work with vagueness, uncertainty, imprecision, or qualitativeness. Now, let's see, we'll take an example how to represent a particular parameter. Say, for example, representation of temperature. So water temperature, how we basically describe the water temperature. So water can be cold, mild, and hot. But to have a crispy or Boolean representation, you have to have a meaning. What do you mean by cold? What do you mean by mild? What do you mean by hot? So we have some numerical values. So let's see, cold means 0 to 20, 20 to 30 is mild, and 30 to 50 is hot. Let me ask you, represent this in another way. we describe the degrees, first division, second division, third division. First division with honors. So anyone who scores 75% and above is first division honors. Okay, so that means 74.9 is first division only, not first division honors. Is there any difference? Difference of 0.01, or maybe it is 74.99. It is first division. Let us see if we talk about the pass and fail. So let's say 35 marks is the passing level. If a student score 34.9, he is not pass, he is fail. So in fact, do you think is there any difference between a candidate who has scored 74.9 who is first division and another one who scored 75, that is first division with honors? So due to lack of 0.1% marks, a student has to live entire life with a complex, I am first division, I am not first division honors. So basically in crispy or Boolean logic, the boundaries are sharp. Suddenly the degree is changing from mild to hot or from cold to. So in some cases, this is not correct. For example, first division in first division honors, second division in first division. So a difference of very small percentage will make a huge change. So let's see, what do we do? In fuzzy logic, basically we use smooth boundaries to represent the parameter. So code here can be defined up to some degree. Let's see, 10 or 12 degree it is cold, but as the temperature increases, the degree of coldness keeps on decreasing. So maybe 20 degree, which is 100% cold here, 19.90 is 100% cold here, is basically some degree cold, but at the same time some degree mild. Let's see, 18 degree. 18 degree is cold, but 0% mild, 0% hot. Whereas in fuzzy logic, the 18 degree is some degree cold, but at the same time it is some degree mild. So now for the same input parameter, I have more flexibility. The 18 degree, which was described as 100% cold, is described as with some degree mild, some degree cold. So more flexibility is given. So on x-axis, we will call it universe of discourse. On y-axis, we will call it degree of membership, that is 0 to 1 per unit or 0 to 100%. Whereas the x-axis, the parameter, say temperature, that is in degree. If it is distance, we may consider meters or kilometers or whatever it may be. And these, the variations of different parameter, water can be cold, mild and hot, they are called membership functions. Now, before we switch further, let me discuss the areas and applications where we are fuzzy logic. So fuzzy logic is used for decision making and control in process control, modeling, estimation, identification, diagnostics, stock market prediction, agriculture, military science. And there is no area left remained untouched where we are not using fuzzy as AI technique for decision making and control. And these are basically named as either fuzzy control or fuzzy pattern recognition, fuzzy arithmetic, fuzzy probability, fuzzy diagnostics, fuzzy neural network theory, etc., etc. Let's see some of the practical application, some consumer product. So like your cameras and camcorders, they are using for image stabilization purpose. Washing machine, I have just taken the example. Refrigerator, vacuum cleaners, and you can see all the multinational companies like Whirlpool, Canon, Sharp, Siemens, they are basically using fuzzy logic control for these consumer products. Automotive and power generation. Now, these days we are talking about EVs, electric vehicles. So in EVs, basically for powertrain and transmission control in automobiles, engine control, and almost all the companies, Honda, Mazda, Nissan, they are now using fuzzy logic for automotive and power generation application. Industrial process control, cement clean, refining, distillation, robotics and manufacturing. These are some of the areas where we are using fuzzy. Same thing I shown with the help of certain in the pictures. So in fuzzy real life application of fuzzy system is washing machine, where you can see that there are different controls are there, either manual mode or fuzzy mode. So in fuzzy mode, you can choose fuzzy 1, fuzzy 2. Let's see, fuzzy auto controller in cars. So these days, in fact, now we are talking about a driverless vehicle, isn't it? So you will simply use the GPS system, navigator, plan your route. It might be possible, program your car and go for a big sleep. Your car will automatically follow the route which you have programmed, or maybe the shortest route, and will take you to the destination. So a lot of human intelligence is required. Say for example, if something comes just in front of you, if your speed is very high, how to take a decision? If an object comes in front of your car, your speed is very high, what do? You apply very high pressure on the brake, isn't it? So basically, human brain will take a decision. I have to stop the car suddenly. So what do? Apply high pressure. Now, what do you mean by high pressure? But we do not have any measurable parameters. But if an object comes just in front of your car suddenly, we know we will apply the brake such that before hitting the object, we will be able to stop the vehicle to avoid the accident. So these decisions are to be taken by the controller. See, this is in 1988, the Hitachi, they basically used a control of a subway in Japan based on fuzzy system. This is the picture of a cement kiln where the limestone is crushed to manufacture the cement. So in this, we are using the fuzzy logic control. Even the image processing, the fuzzy decision makings are used. In fact, recently we have a new experiment in the country for celerity in the courts. So model case complexity of criminal justice system, the fuzzy decision making theory is being applied. Basically, what we are doing is that we are taking the decision making and selection of courthouse building. Say, for example, adult criminal court system in British Columbia. In your photocopier, see, many times in the photocopiers and printers, if your papers are having the moisture, then 2-3 papers may proceed together and may jam your machine. So in fact, we use the fuzzy theory for adjusting the drum voltage based on picture density, humidity and temperature. In fact, in the escalator systems, elevator modeling and control, we are using again the fuzzy system. So there are several, wherever you need to take a decision, we can apply a fuzzy theory if your inputs are vague, not well defined. So this we have already discussed. Let me skip this. Yeah. So the basics of fuzzy logic, we basically have a fuzzy set theory where we classify the fuzzy and classical sets. Then we define the fuzzy membership function. We design a membership function, and all these inputs, the variables are described in terms of linguistic variables. Then we need to have the distribution of these membership function on a probability. Further, we apply the if-then rules based on our knowledge, and we'll use the fuzzy operator to linking the rules. These are some example of the fuzzy membership function. So you can see this is a triangular membership function. This is symmetrical, this is asymmetric. So here my membership function will start from 2, will have a peak at 4 and will stop at 6. So maybe this may be a variation of a membership function, say for example speed or distance or temperature, whatever it may be. It may be symmetric, it may be asymmetric. This is the trapezoidal variation where we say that in some set of input parameters, my input is, the degree is constant. This is Gaussian, this is bell-shaped and sigmoidal left and sigmoidal right. Some example of membership function. Now, as far as the internal structure of a fuzzy system, it has three main components: fuzzification, decision making, and defuzzification. Fuzzification is basically the classification of input data into suitable linguistic variables. So whatever the inputs are there, we have to convert. Say for example, if water temperature is the input, so defining the linguistic variable that water is cold, mild, or hot, or very hot, or extremely hot. This is basically, what do you mean by cold? So 0 to 10 degrees cold, 10 to 15 degrees mild, 15 to 20 degrees. This is fuzzification. Then we'll have the decision making box, that is rule based. So this input is basically evaluated based on certain inputs, rules, which are similar to human thinking, if else kind of. And then finally, the output we defuzzify to bring it to the real-time word system. So we'll understand with the help of a very simple system. We all will go to the restaurant for giving, for parties, taking dinners. We have a provision of giving the tips. So in basically many developed countries, there is a thumb rule of giving 10 to 15% of your bill amount as the tip, a very fixed way. Okay, but this is not a correct way. The tip is mainly based on either service quality or food quality, isn't it? So let's see, we can have another formula that will have some fixed component, but some percentage weightage is given for the service quality. That is a very realistic. If service is good, tip is good. If service is very good, tip is very good. If service is not good, tip may be either zero or least. But we have to offer some service provider, then some minimum. So with this formula, there is a possibility of giving the tip from 5% to 25% based on my service quality. Now, what do you mean by service? How to measure it? So generally, we can see, you can rate it on 0 to 10 points. 10 means service is very good. 0 is service is very worst. Say 5 is average or something like that. This is how generally, when you go for car servicing, they will ask for a feedback about the service, isn't it? In many restaurants, they will ask for the feedback from the customer based on the points given for service, food quality, etc. So this is the only one input variable. So not correct all the time. Say for example, if you go to some restaurant, the service was excellent, but food quality was worst. Do you give the tip for that? So basically, we'll have another parameter, that some fixed component, but some percentage weightage of service as well as food quality. So on one axis, x-axis, we have the service. On y-axis, we have the food quality, isn't it? Now, again, some marks are given from 0 to 10 for service, for 0 to 10 for food, and then we decide the tip. So now this is the surface area based on the input, different combination. If your service is say 9 point, if your food quality is say 3 point, somewhere here will be your tip. So with this particular formula, we'll have the which was a straightforward decision has become a very complex decision, how much tip has to be given. Now, in the fuzzy approach, basically, how do? We will use a if-else kind of thinking. If service is poor, obviously, then tip is cheap. This is the rule. If service is good, tip is average. If service is excellent, then tip is generous. If I consider the food into effect, if food is rancid, then tip is cheap. If food is delicious, the tip is generous. But when we combine both the inputs, so let's see, my rule will become, if service is poor, or the food is rancid. Now let's see, we are using an operator. This may be if service is poor or the food is rancid, then tip is cheap. Or you can write if service is poor and the food is cheap. So like a boolean or an AND operator, the same is used here as well. Or is max operator, whereas AND is min operator. So it depends. It depends on the user. Let's see, as the tip provider, if I am writing the rule, so we wanted to give less. So we will use the max operator. So how I will write, if service is poor and food is rancid. When both are good, only then I'll give the tip. Whereas if waiter is writing the rule, in this case, giving service his duty, food quality is not. Food quality is maybe based on the cook who is preparing the food, based on the raw material used by the owner. So if waiter is writing the rule, he will write if service is poor or food. In either case, he will get the tip. Maybe your rule can be if service is good, then tip is average. We are not using any parameter for food quality. But let's see, if service is excellent or food is delicious, then tip is generous. This is something very realistic. This is something very realistic. That means if service quality is very good and food quality is also very good, my purpose of giving a party is served, then we will give very generous tip. Okay, so this is basically that is, these kind of rules needs to be framed to take a decision. Now this is the entire fuzzy inference system for restaurant tipping. My input 1 is service, input 2 is food quality. Your service, maybe you have to give some marks between 0 to 10 for input 1 and 0 to 10 for food quality. Then you need to fuzzify. Fuzzify means these the inputs defining their linguistic variable. Say for input service and food, your numerical range is from 0 to 10, and your membership function can be for service, it may be poor, it may be good, it may be excellent. For food, it is bad and deal. Generally, food either you like or you do not like. That is why I have considered only 2 membership function. Either it is bad or it is very good, delicious. But you may add, okay, so average food quality, that also is possible. But it again depends on what type of decision. Let's see, if I am giving a party on some occasion, we want delicious food only. So either it is very good, food has to be delicious, even if there is any deviation, we will say no, it was because I have paid for it. I have paid for it and my guests have not enjoyed the food, so I will not give any marks. Either it should be excellent, it should be very delicious, or there is nothing doing in between. Then similarly for the output, my tip, that is numerical range is 0 to 20% of my bill amount, whereas the membership function can be, your tip can be cheap, your tip can be average, or tip can be generous. So all this is the part of fuzzification, where the input we have given the numerical range, we have defined the linguistic variables, and we have defined the membership function. Then we will write the rules. So in fact, rule may be this, or when we combine both the input. So how many rules are there? Very simple formula: number of membership function into input 1 into number of membership function into input 2. So here 3 and 2. So 3 into 2, 6 rules are there. If there are 3 inputs, then number of membership function in 1 into number of membership function into 2 into number of membership function in input 3. So let's say there are 3 input with 3 membership function each, then 3 into 3 into 3. So 27 rules will be there. If there are 3 input with 7 membership function, then 7 into 7 into 7, that is more than around 250 rules are there. That is the real complexity. So every rule will give you one output. So n number of rules will give n output, then you have to aggregate this. The output of each rule is combined, and then finally you need to find out a single decision to give the tip. So tip may be cheap, average, and generous. But what do you mean by cheap? What do you mean by average? What do you mean by generous? Ultimately, it has to have some numerical value. 25 रुपए, 50 रुपए या 100 रुपए. If I'll say 10% tip, it has to ultimately convert it into some the measurable parameter rupees in this case. So let's see, this is the example of membership function. This is my variation for poor, this is for good, this is for excellent. So I have used a trapezoidal for poor and excellent and triangular for good. I mean, it's up to you. No defined rules. It's again based on your experience. Similarly for bad and delicious, so if anything greater than 8 or 9, I am considering. All other case it is 0. Similarly for the tip, it may be cheap, average, or generous. So I've shown you different type of membership function: triangular, trapezoidal, Gaussian, Gauss-Bell. Generally, based on our experience, we will choose these membership function. Then we'll form the rule base using the if-then rules. So the third combination we have used: if service is poor or the food is bad, then tip is cheap. So this is my basically information processing in a fuzzy inference system for restaurant tipping system. So you can see this is my input 1, poor, good, and excellent. This is my membership function input 2, bad. There is no basically membership function in rule 2, and this is again delicious for rule 3. So my rule 1, these are, you can see here, poor, good, and excellent for service, bad and delicious for food quality, and cheap, average, and generous for tip. So you can see, let's see, if my service, someone has given 3 points, food is 7.5. What does it mean? That food quality is above average, 7.5 marks out of 10. That means food quality is good. It's close to very good, but service is very poor. So generally, the tip is given more for this service. So food quality was good, but you were not attended properly. The food was not served on time. So in this case, if we talk about the general decision, so service is poor, though food is good, your tip should be below average, isn't it? A right decision should be, tip should be below average. Let's see how we calculate it from the rule. If service is poor, so service 3 is having intersection with poor membership function as 0.5. Food is bad, so 7.5 with bad membership function at 0. And I am using the OR operator. So OR 0.5 or 0. So OR is basically max operator. So out of 0.5 and 0, I'll choose the maximum output 0.5. 0.5, that tip is cheap. So this is my cheap membership function, and 0.5. So basically cheap membership function truncated with 0.5 is my output. Similarly, for rule 2, if service is good, then tip is average. So good is having, service is having intersection with good at 0.3. There is no components in second input part, and this is average output. The tip is average. So average at 0.3, intersection, truncated, average membership function is second output. Similarly, service for the rule 3 is excellent. So it is 0. Food is delicious. So 7.5 is having intersection. This is not 0.4, 0.2 with delicious membership function. And again, I am using the OR operator. So 0 and 0.2 is the OR highest, the max operator. So 0.2 with generous is my output. So this is my output 1, this is my output 2, this is my output 3. Now we will combine. This is called aggregation. we'll combine this output, and this output. This is my aggregated output. Now, here I have to take a simple decision what should be my tick. So you need to apply the defudgification. So for defudgification, basically center of area or center of gravity is finding the center of gravity or center of area of the shaded portion is one possible way. So based on that, your tip comes to be 8.5%, which is less below average, which is very correct as compared to we practically think. So what I can say that the rule base I have framed is giving me satisfactory answer. So this is defudgification is basically center of area. For implication and aggregation, there are several methods are available in the literature. Mamdani type, Lusing-Larsen or Sugno type. See, what is the difference? In Mamdani type, what we do, this your output is truncated to the defined membership function. Whereas in Lusing-Larsen type, what do we do? If this is my output, what do we do? Instead of truncating, we'll create another area within the membership function. Say, for example, this case, my output is 0.36. We have created another triangle with 0.36 as a. So this is my shaded area. So these two methods you can see here, the area is more, this one is less. So definitely your output will be much. This is another method of defudgification. This is the here instead of considering the entire shape, what we will consider only designated point in their membership function. And discrete systems, we apply this theory. So 1 into 0.4 plus 2 into 0.4 plus 3 into 0.6 plus 4 into 0.6 plus 5 into 0.8 plus 6 into 0.8 plus 7 into 0.8 divided by these degree of membership 0.4 plus 0.4. So this will give you the out. So this is how basically we apply the this is another method, only height method. In height method, what do? Here we have taken 1, 2, 3, 4, 5, 6, 7 points. Instead of this, only the highest point of the membership function is considered. So for this particular membership function, this is midpoint. For this particular membership function, this is midpoint. So 2 into 0.4 plus 4 into 0.6 plus 6 into 0.8 divided by 0.4 plus 0.6 plus 0.8. So that is 4.44. So previous case, my output was 4.5, whereas in this case, it is 4.44. It's almost relatively close. 4.44 and 4.5 are almost close. In this case, my complexity is much less. So with less mathematical manipulation, I'm able to get the similar result. So generally in discrete system, when you have to implement your control digitally, we will prefer these type of methods. This is another method where center of gravity is taken for the largest area. The highest membership function is considered. This will definitely will give you the high output. So now, if a waiter is preparing the rule, he will prefer this particular method. If the one who has to give the tip is preparing the rule, he will prefer this method. So it's again, you have to take a decision logically which particular method is good enough. So now let's see, we'll come to a case of designing and control implementation using fuzzy. So what the very first step is that we have to analyze whether the problem has sufficient elements. Prashant, do you want a break of few minutes or shall I continue?
Continue, sir.
Shall I continue or you want a break?
You may continue for 15 to 20 minutes. Then we will have a question answer session.
Okay. So basically we have the certain steps involved. You have to analyze the problem that has sufficient elements such that it deserves to be a fuzzy control system. Generally, see what happens, everybody is using fuzzy control, I should use the fuzzy. This is not the logic. You have to analyze, yes, whether my inputs are really vague, I'm not able to make, it's a really non-linear system, I'm not able to make a mathematical model, yes, I should go for the fuzzy. So this is basically the very first step you have to think for. Then you have to get all the information from the operator of the plant to be controlled. So as I told you, your experience matters. You have to collect the information most of the time. Say for example, if you are taking some strategy of marketing a product, what do? These people will do a market survey from the consumers. So they collect the sample. Say for example, in polling time, they basically give the opinion poll which party will form the government. So how they collect this sample based on the geography, based on the area, based on the age group of the people, based on the gender, based on the caste, several. They collect the sample and then come to a final decision, yes, this will be the outcome. So collecting the information, in case of control, it is you have to collect the information from the plant. Then if a plant model is available, develop a simulation program with the conventional control and study that. Identify the control element where fuzzy logic is being applied. Then input and output identification and universe of discourse need to be defined. So then next we will determine the fuzzy sets and corresponding membership function, determine the rule table, determine scale factor of the variable. If model is available, simulate the system with the defined fuzzy controller and observe the performance under different condition operation. Okay. Then finally, we will prepare a rule table and membership functions to test the controller. And finally, we will implement the controller in real time. So just to implement a fuzzy control, let's see, I will take a closed loop control of DC to DC controller. So in DC to DC controller, what do? This is a buck converter. In buck closed loop control buck converter, basically this is my input voltage. So control switch, and these are the L and C component, and R is the load. So what do? We will set the desired output voltage, and accordingly the duty cycle of this controller, this switch is being controlled, isn't it? So what do? Basically we select a reference value, what is the desired output voltage, which is compared with the reference value. And this error signal is processed in conventionally a PI controller or a fuzzy controller. And what do? We generate a control signal. This control signal is compared with a carrier signal, isn't it? So you can see here, this is my ramp signal or any other, just I have taken an example. So this is my carrier signal. With this, we are controlling this V control, and these pulses are generated as a duty cycle on and off control of this particular switch. So let's see if we need to implement this. We have to characterize 7 fuzzy sets for each input and output. Just for simplicity, we are using triangular membership function, fuzzification using continuous units of discourse, implication using Mamdani's min operator, and defuzzification using center of area. Now, how many membership functions to be chosen? Because your error can be positive, it can be negative. To have the symmetry, we'll have the membership function 0, positive and negative. Generally, and that is why. Otherwise, you can have even the even number as well. But in this particular case, we are choosing the odd numbers, either 3 or 5 or 7 for the symmetry. Then how many membership functions are to be chosen? Generally, if we see the different cases, people have used up to 5 to 7 membership functions. You can go even beyond 7, but complexity will increase with not much improvement in the output. So generally up to 7 membership functions are tried in different type of controller, which will give you perfectly good results. So this is the simulation model we have created. Input source, load resistance, and output voltage we are measuring. This is compared with the reference value. So let's see, my input voltage is 1500 volt, whereas I wanted to maintain 1100 volt at the output. And accordingly, I have to control the duty cycle of this converter. So for a fuzzy controller, we'll have two inputs. Minimum two inputs are required. So one is error and another one is change in error. So d by dt of error is taken as second input, change in error and error. This is processed in fuzzy controller to generate the firing signal duty cycle for the. You can see here, this is the MATLAB window FIS editor, error and change in error. This is my fuzzy rule base and this is the output. So you can see, just for simplicity, for error and change in error, triangular membership function are chosen. 0, this is my 0 membership function. Then we'll have positive small, positive medium, positive big. Positive big is chosen trapezoidal. Anything greater than 0.75 error is positive big, having one membership function. Just for symmetry, 0, positive small, positive medium, positive big. Here, negative side, negative small, negative medium, negative big. For simplicity, as I told you, I have taken a common membership function with common variation of the distribution of these membership functions. Okay, I mean 0 generally it means anything 0.1 minus 0.12 plus 0.1 or minus 0.12 plus 0.1. It depends how much accurate system you want. Then what do? We'll make a rule table. So on one axis we'll have the error. Your error can be 0, positive small, positive medium, positive big, negative small, negative medium, negative big. Similarly, change in error can be 0, negative small, negative medium, negative big, positive small, positive medium and positive. Now we will write the rules. So 2 inputs, 7 membership function. So 7 into 7, 49 rules need to be written. How a rule can be, if my error is negative big, change in error is negative big, your basically the output, the control signal should be positive big. If your error is negative big, but change in error is positive big, basically no need in control change is required. Likewise, now see, this is the output of the fuzzy controller for the buck converter. So you can say this is the output of fuzzy controller, whereas this is the PI controller. My output is 1100 volts. See, output is maintained constant 1200. With fuzzy, you can see there is no overshoot at all. Whereas in conventional PI controller, initially my voltage overshoots to around 1300 volts. And the settling time, you can see output is varying very smoothly and it reaches to steady state even much before then it reaches to steady state in conventional PI controller. So both the aspects, overshoot as well as settling time, are better with fuzzy controller in this particular case. So let's see, if I have to choose a semiconductor, as with the PI controller, my maximum voltage is going up to 1300 volt. So while selecting the rating of this device, I have to apply the safety factor in 1300 volt. Whereas in fuzzy controller, because there is no overshoot or very little overshoot, I wanted to maintain the 1100 volt output. So into that will be the safety. 1500, because your minimum device voltage has to withstand 1500. But if your overshoot is even more, so let's say if it is going to 2000 volt, in that case you need to choose a device with a higher voltage stress or higher voltage rating. So what we can say that in this particular case, the transient response of PI controller is better. In fact, the fuzzy control is also applied in motor control application. In motor control, it is observed that transient response of fuzzy is better, whereas steady state response of PI controller is better. So in that case, we will also use the hybrid controller, fuzzy PI controller. That is, if I am in transient, sudden change in the load is there, we will use the fuzzy controller. In a steady state, we will use the PI controller. So this is how, as we have told you, that the experience from the plant operator or model is needed. So these are the variation of error. There are 4 different patterns are there. The step response of any general system. Either we may have like this, or this may be basically underdamped system. So we'll have the overshoot, undershoot, and then we'll settle. This is the unstable system. In unstable system, basically our error keeps on increasing and your controller will never reach to the settling limit. So basically any particular step response of any system will have these 4 possibilities. Generally, this is most common, that will start from 0, will reach to a maximum limit, overshoot, undershoot, overshoot, undershoot, and with some time. So you can see we'll have 4 different areas: A1, A2, A3, A4. A1, this is my reference value and this is the actual value. So reference minus actual, your error is negative. This is the A2 area where your error is positive, but slope is basically positive. This is A3 area where my error is negative, reference minus actual negative, but slope is changing. Similarly, in A4 area is similar to A1, where reference minus actual is, that is, error is positive, but here the slope is positive, here the slope is negative. So your entire response is divided into these 4: A1, A2, A3, A4, and you can optimize the switching response. So your 49 rule table shown here, this can be basically classified into these areas. You can see A1, A2, A3, and A4. Then we will have these points, B1, B2, that is 0 error point, and C1 and C2 where your error is maximum positive or maximum negative. So you can see the entire 48 rules are now classified into 1, 2, 3, 4, 5, 6, 7, 8, and 9 zones. This is the area where 3 by 2, 3 by 3, there is some variation here, 0, negative. 3 into 3, 9 rules, another 9 rules, another 9 rules, another 9. So that is how, if your basically error and change in error in this particular area, you can see there is a pattern involved, 0, 0, 0 on this particular diagonal, whereas let me take this to a, yeah, you can see here, this is the 0 axis, then we'll have the negative small, negative medium, negative big, and so on. Similarly here, positive medium, as a particular pattern is being generated. So there are several optimization techniques we'll use to reduce the number of rule which needs to be fired at a time. Yeah, yes, you can see here, all this is negative big, negative big, negative big, negative big. So except this particular case, these the rules, 49 rules are optimized if we are able to identify these areas. So this is again a repeat. This is the another case of an active power filter. So you can see that this is the fuzzy controller, whereas this is PI controller. Source voltage, source current. This is compensated current, which is sinusoidal. Load current is non-sinusoidal, whereas source current is sinusoidal. And you can see this is my DC link voltage, isn't it? DC link voltage, you can see the overshoot here and here. With conventional PI controller, the overshoot is much larger. Again, the settling time, even at 0.15, the output voltage is not settled. Whereas in fuzzy controller at 0.12 second, the output voltage is settled. if we talk about the load change, load perturbation response, in this case also you can see the settling time we have settled much before 0.35 seconds, whereas in PI controller your output voltage is not settled up to 0.4. So another 2.5 cycles my output voltage is not set. So this is how we can say that the transient response of fuzzy controller is better as compared to the conventional PI controller. This is the phase plane trajectory you can see here. The phase plane trajectory, we are starting error from 0 and red is fuzzy controller. So you can see that the blue is PI controller. So there is a finite steady state error is there with the PI controller, whereas in fuzzy controller, the steady state error is also very less. Both these cases, this is for sudden decrease in load current, this is sudden increase in load. So for this particular case, we can say that both my overshoot and is less, settling time is also better. So that is how we can say that we apply the human intelligence for controlling power electronic converters with the human thinking if then else rule kind of thing. So we will select the input, fuzzify them, apply the rule base, then finally find out the output, defuzzify to implement the control. You can see this is the case, a transient response of a diode rectifier feeding RC load. So it's a very, dangerous kind of load with high non-linearity. This is the transient response C. Very less overshoot is there, whereas in this particular case, the overshoot and settling time both are high. So we can conclude here is that without having accurate mathematical model, we can apply the fuzzy system for power electronic converter. Then it is observed that the transient response is better in some cases. Uh, then we will see that the transient response is better, and in fact in this particular case of active power filtering, even the steady state response with error in steady state is found better with fuzzy controller as compared to PI controller. So with this, let me extend my thanks for a monologue kind of thing. When we'll interact with each other, I know there might be many questions in your mind you would like to ask, but in fact it was not possible to interact in between. Now I request if some of you are having the questions, I'll try to answer them. Thank you.
Thank you very much, Jain sir, for your valuable guidance. Now I request the participants to ask some questions if they have any queries. There is a request to all the participants that if you have any queries, you can also put it in the chat box. The chat box has been kept open for you. Okay, so if you have any questions in this session, you can ask orally also. But
in fact, let me inform Prashant, whatever I have discussed, I have authored a book on modeling and simulation using MATLAB Simulink. In that,
circuit. लोगों को डायरेक्ट पूछना दो क्वेश्चन, अभी चैट पे पूछना। जैन सर
okay.
So,
हाँ
in fact, my battery basically vanished. So I simply put it on the power. Okay. So whatever I have discussed, this is in that particular book, an entire chapter is devoted on fuzzy introduction as well as use of fuzzy toolbox. So I think you'll find many books on fuzzy, but those are on fuzzy systems, fuzzy algebra. Whereas our objective is applying the fuzzy theory for control purpose. So you need not to go for that learning the fuzzy algebra, rather how this can be effectively and briefly discussed. So those who are interested to work with fuzzy decision making and control, they can refer.
So any questions from the participant side? Yes, you may ask the questions.
Sir, I have one question.
Yes, please.
Yes, you may go ahead.
Sir, what is the implementation complexity? Fuzzy, I have read in some of the research paper that the complexity of the fuzzy logic is quite high, sir. So,
In fact, it depends what type of membership functions you are using. When we need to implement it digitally, in that case, that is what all my discussion I taken the triangular membership function, isn't it? So triangular membership functions are easy to implement in real time. But if you are using some simulation package, then you can go for the Bayes, Gaussian, whatever it may be. So in fact, in neurofuzzy applications where you require the smooth variation in membership function, Gaussian, Bell-shape, they are used. Rest of the cases, if you require the linear variation, then we will prefer the triangular and trapezoid. So with that, the main thing is that it is not the complexity. It is optimization of number of rules to be fired at a time. So the for active power filter which I implemented, out of 49 rule, only 4 are fired at a time. 45 are ignored. So that is what you have to consider. So with this two membership function overlap, only 4 are fired. If there are 3 membership function overlap, then probably complexity is high. So that you need to consider while designing, framing the rule base of your system, and you have to think for the optimization so that for effective control, only the rules which are effectively applicable in this particular area needs to be applied. That will reduce the complexity.
So any other question? Yes, you may continue. Ask the questions. Okay, Jain sir. So I think we may conclude now.
Okay.
So thank you very much for accepting our invitation as a chief guest, as well as to deliver one session. So thank you very much, sir.
Thank you. My best wishes.
Thank you, sir. Thank you very much.
Okay.
And I request, हाँ sir.
द केके का जो लेक्चर हो रहा है, आप उसकी लिंक भेज दीजिएगा मुझे. आई ट्राई टू लिसन हिम एज वेल.
Yes, sir. Yes, sir. Yes, sir.
Thank you.
Okay, thank you. I request all the participants to join at 2:30 p.m. for the practical session, which will be conducted by National Infotech Surat. So now it's over, and we will rejoin with the same link at 2:30 p.m. And feedback will be shared in the evening. Okay. So thank you very much for your patience hearing. And from the next session, we expect that we have some questions from your side, and you can put it in the chat box also. So thank you very much.